In this video, let me consider one numerical on Z transform. Determine the transfer function and a difference equation representation of an LTI system described by the impulse response h of n. Here h of n is given. We are supposed to find the transfer function, that is h of z, and the difference equation. Let's see how to calculate this. So here the transfer function means h of z. So h of z is obtained by taking z transform of the given impulse response signal, that is h of n. So here for easy simplification, I will consider the first part as h1 of n and let this part as h2 of n. Let's calculate the z transform of h1 of n and h2 of n. By adding those two, we'll get the z transform of h of n, that is nothing but h of z. First, let me calculate the z transform of h1 of n. That is h1 of n is equal to 1 over 3 power n u of n, power n u of n. So we know that z transform of alpha power n u of n, the z transform of this is given by 1 upon 1 minus alpha z inverse, where ROC is z is greater than alpha. So here alpha is nothing but 1 over 3. Therefore z transform of this is h1 of z is equal to 1 upon 1 minus 1 by 3 z inverse, where z is greater than 1 by 3. So now similarly, let me calculate the z transform of this term, that is h2 of n. h2 of n, that is h2 of n is equal to, we have 1 by 2 power n minus 2 u of n minus 1. 1 over 2 n minus 2 u of n minus 1. I will rewrite this expression as 1 over 2 power n minus 1 into 1 by 2 power minus 1, which is same as 1 by 2 power n minus 2 u of n minus 1, or I can write it as, so 1 over 1 by 2 power minus 1 is nothing but 2 into, we have 1 over 2 power n minus 1 u of n minus 1. We know that z transform of alpha power n minus 1 u of n minus 1 is given by z inverse 1 minus alpha z inverse. So therefore this is by shifting property, that is shifting property by shifting property. So therefore now I will apply shifting property to this term. I can get z transform of h2 of n is h2 of z is equal to, here we have 2 is constant, is kept as it is, z inverse, that is here z inverse divided by 1 minus alpha is nothing but 1 by 2 z inverse. So therefore h of z will be h1 of z plus h2 of z. Therefore I can write h of z is equal to, we have h1 of z, that is 1 upon 1 minus 1 by 3 z inverse, plus we have another term, that is 2z inverse divided by, we have 1 minus 1 by 2 z inverse. So now I will simplify this further. So here h of z is nothing but transfer function. I will simplify this. H of z is equal to, here I will take the LCM as 1 minus 1 over 3 z inverse 1 minus 1 by 2 z inverse, and here I can write 1 minus 1 by 2 z inverse plus, so multiplying 1 with this term is 2 z inverse minus it is 2 by 3, 2 by 3 we have z inverse into z inverse, that is z power minus 2, or I can simplify this further as, that is 1 minus 2 minus half is half, 1 3 by 2 z power minus 1 minus 2 by 3 z power minus 2. On denominator I will multiply these two terms. I can write it as 1 minus 1 by 2 z inverse minus 1 by 3 z inverse plus 1 by 3 into 1 by 2 is 1 by 6 z inverse will be z power minus 2. Therefore further I can simplify this as h of z is equal to, on numerator we have 1 minus 3 by 2 z inverse minus 2 by 3 z power minus 2 whole divided by, on denominator we have 1 minus 1 by 2 plus 1 by 3 will be 5 by 6 z power minus 1 plus 1 by 6 z power minus 2. So this is the required transfer function h of z. H of z will be equal to y of z divided by x of z, that is output by input. So therefore this equation is nothing but y of z divided by x of z. Further I can simplify this as, I will take this term on this side and this term on this side. I can represent it as x of z into, we have the numerator, that is 1 minus 3 by 2 z power minus 1 minus 2 by 3 z power minus 2 is equal to, we have y of z into 1 minus 5 by 6 z power minus 1, then we have 1 by 6 plus 1 by 6 z power minus 2, or I can represent it as x of z minus 3 by 2 z inverse x of z minus 2 by 3 z power minus 2 x of z is equal to y of z minus 5 by 6 z inverse y of z plus 1 over 6 z power minus 2 y of z. Now let's take the inverse z transform of this by taking inverse z transform. So we know that the inverse z transform of x of z is x of n minus 3 by 2 is constant, 3 by 2. Inverse z transform of z inverse x of z is x of n minus 1 minus 2 by 3. It is x of n minus 2 is equal to, here we have y of n minus 5 by 6 y of n minus 1 plus 1 over 6 y of n minus 2, or I can write it as y of n is equal to, we have x of n minus 3 by 2 x of n minus 1 minus 2 by 3 x of n minus 2 plus 5 by 6 y of n minus 1 minus 1 by 6 y of n minus 2. So this is the required difference equation. This is how we supposed to calculate system transfer function h of z and difference equation. Thank you for watching.